we're going to look at the nomenclature of these carboxylic acids. So, starting with the first one, how do we get to name it? Well, we first need to look at the most principal functional group present, and in this case, we've got the carboxylic acid as a functional group of highest priority. So, carboxylic acid functional group wins when it has got any other functional group with it, and so in naming, you always have to give it a lower number. And so, all the other groups here are going to act as substituents, the hydroxyl and also the methyl. Hydroxyl comes first in the alphabet, so this will be 3-hydroxyl, 3-hydroxy, and then at position number 2 we have got a methyl. This chain has got 4 carbons, so that is going to be butanoic acid. And then considering the next one, again we're going to give a lower number to the carboxyl functional group. Whenever a carbonyl is attached to an hydroxyl directly, that forms a different functional group, which is a carboxylic functional group. This will be position number 2, number 3, number 4, and number 5. Well, in this case, this is a ketone, and when a ketone acts as a substituent, we name it as oxo. This is a methyl, and we know M comes first in the alphabet, so we first name 2. At position number 2, we've got a methyl, so that will be 2-methyl. And then at position number 4, we have got oxo. The whole chain has got 5 carbons. That will be pentanoic acid. And then looking at the other one, this will be position number 1, number 2, number 3, number 4, and number 5. So the only group which you have here is a methyl at position number 4. So that will be 4-methyl. Now you can see that at position number 2 we have got a what? A double bond. So this is going to be 2. This is a chain of 5 carbons. It was supposed to be pentene. But because this is not the parent name, so instead of it being pentene, it will be just pentene. Okay. Now we remove the E at the end and put oic acid. So that's the name, 4-methyl-2-pentanoic acid. Now, let's say this wasn't a double bond. Let's say this was a triple bond here. How would the name change? So this is now an alkene. So as we get to name it, we need to pay attention to understand that this is an alkene, and it ends for an alkene when you are even naming it, the nomenclature of alkenes. So this was supposed to be pentene, like that. So I'm going to remove again the E at the end, and so this will be pentene, and then we'll put oic acid. So that's the name. So this gets always to end in noic acid. And then for this one, we have got a chlorine at position number. Okay, how do you tell which one will be position number 1? We'll look at these groups. Now, this functional group, can you try to identify it if you can? Yes, this is a carboxylic functional group. This can also be written as C double bonded with oxygen and then OH. It is a carboxylic functional group. And so when we are naming, this will be position number 1, position number 2, number 3, number 4, 5, and 6. Now because of this, we can see stereochemistry here. This means both of these are coming towards us. And because of this, we are going to put cis, because they're on the same side of the plane. And then at position number 2, we have got a chlorine. So 2-chloro. Now this is a cycloalkane, and it has got 6 carbons, so cyclohexane. But I'll remove the E at the end because it's not hexane, it's hexanoic acid. So, but one other thing that you need to pay attention is, it was supposed to be yes hexanoic acid like that, but notice that this carbon in the longest chain, we didn't count, this carbon of the function of the principal functional group, we didn't count it as we are naming what? The longest chain, or numbering the longest chain. So whether it is aldehydes or carboxylic acids, or even amines. When we do not name the carbon, amides, I mean, or even nitriles, aldehydes, carboxylic acids. When we don't name this carbon, which is part of the many or the principal functional group, we always need to put carba there. So this is going to be cis-2-chlorocyclohexane. So we'll just finish the name hexane, and then now we're going to put carba. So now this is an acid, so it will be carboxylic acid. So that is going to be the name. Now say if this was not a carboxylic acid functional group, if this functional group, let me put another one there, so just see if how the name would have been. If this functional group was for an aldehyde is a carbon double bonded to an oxygen and then an H. If it was like that, which I can also show just like this, COH, how would it have been? So this is not CO2H but COH, that is an aldehyde. So it would have been cis 2-chlorocyclohexane and then carbaldehyde, because we've not named that carbon in the main functional group. And then if this was a nitrile, so let me get to remove this. A nitrile has got a functional group CN triple bonded to N. So this would have been cis 2-chlorocyclohexane, and then we put carbonitrile. So that is how we get to name this when we are not counting the carbon or the longest chain. Well, thank you so much for watching. Enjoy your day.